right, thanks, Justin. I did want to start off by thanking this year's lead class that is organizing this. It seems great, especially with a lot of us teleworking, to be sharing all this information. Of course, the regional support as well. And I did want to put a plug out too for all the shift workers out there holding down the forts, you know, doing the extra workload too that's come with a lot of this. So kudos to everyone. Well, I wanted to share a case from the La Crosse service area from last Memorial Day. This was actually on Monday, Memorial Day of 2019. It was an interesting case. You know, I don't know what everyone typically does for their Memorial Day. You might do barbecues, you know, might be planning picnics. This is all, of course, before the COVID experience we're all enduring. I myself, with another coworker, were headed to a craft brewery down in Northeast Iowa, and the day got switched quickly for us, and this is how we ended up spending that Memorial Day, basically on gravel roads, dirt roads in parts of Northeast Iowa and in southern Minnesota, doing damage surveys right after the event. So it was an interesting case for us. There were 7 tornadoes in our area. You can see the numbers there. You know, they were all small, but 5 EF0s, but they had some long path lengths. And the interesting thing, there was no other severe weather. It was tornadoes or nothing, I guess you could say. The holiday aspect of it made it interesting, especially talking to the forecasters that were working that day, from a sense of, you know, not just a staffing issue perhaps, but more of, you know, you didn't have the media presence, might not have been around like usual. People were doing their activities, and so you had those kind of things to consider. There were no injuries or fatalities, luckily, with these cases, and just basically property damage in the area. And these are some of the pictures that were taken. I'll try to show a little bit of video at the end, but damage to a county fairgrounds and several homes and businesses as the tornadoes kind of tracked into southern Minnesota. So I guess for me, and when I wanted to review this, and the question comes down, was this predicted, or is this a predicted type of event? And really, it's kind of a yes or no. Certainly, when I go through the information here this morning, you might be thinking, well, there was certainly a lot of evidence there, but it was very conditional, and that was the thinking going into the day, that there was a risk, but it was very conditional. There was never any watch put out, and I'm certainly not doing this review today to play down any of the you know, services. It was just kind of what happened and how could we do things better, I guess you could say. The report of a tornado did prompt the initial warnings, so that kind of really made the services and the warnings, of course, switch modes quickly, and kudos to the crew that did that on a dime. So just going into some of the meteorological data, just with a variety of fields here, I'm not going to get into too much detail, but I just wanted to show you the big picture here of what the upper airflow looked like. On that day, there was a short wave coming out of the Central Plains, headed up this direction in Northeast Iowa, southern Minnesota. I do want to say too, I do kind of a comparison of some of the fields between 15 UTC, 17 UTC, you know, 10 to noon or so, late morning time frame, with the idea that the tornadoes basically occurred in that 12:30ish to 1:30ish, so 1700 to 1830 UTC or so. So a lot of the data we'll end up with looking at is the 1700 UTC fields. Here's just a quick look at the deeper shear that morning, and there was plenty of shear around even the mid-levels as that wave was, the westerlies, the mid-level flow was approaching the area. Probably more importantly, though, is to, you know, look at the surface pattern in the synoptics of it. This is just a look at 10 a.m. that morning, or 1500 UTC, and there was kind of an MCV. I'll show you coming, approaching the area. I can see the warm front kind of stretched across the region here, far northern Iowa, and I did overlay the surface temp dew point field from SPC on there, just with the idea that the dew points were a big factor here. If you look at, again, the difference across that warm front here, and by the way, the orange circle you'll see in a lot of these graphics kind of represents the area where the tornadoes occurred. But you can see the difference from mid-50s dew points to the north where there was rain falling and much cooler, more stable air mass compared to the kind of hot zone just to the south. And of course, this played a big role in the tornado genesis and making a less than favorable field more favorable, I guess you could say. So just to show you a satellite view at again, a couple hours ahead of time, and you can see a nice clear MCV and some clearing coming to the south. And one look at the radar. Again, I think a lot of our focus that day was on the rain. We'd had a wet spring, so some possible flooding, and you kind of get in that mode perhaps that we've got this cool rain around. It's going to keep things stable. So that was going into some of the forecast processes. Well, speaking of which, I just wanted to kind of show what was out there. This was the day one SPC outlook. The focus was certainly with that wave, but focusing a little bit further south, maybe closer to I-80, where of course the higher dew points in warmer temperatures were existing. And I'm not going to read through all of the writing here, but basically they were focusing on the strengthening mid-level westerlies across this region, and in the second paragraph I highlighted there, some uncertainties existed concerning warm front positioning, and that was indeed some of the challenges locally here that I'll show you. This was the tornado probabilities that day, and I will say later that morning they did nudge up the 2% a little bit into the area. So again, there was some concern about, and here's kind of the verification of the tornadoes with the early morning tornado issuance, probability issuance there. But they did adjust it a little bit, some concern about the warm front nudging a little bit further north. As far as locally, this was out of our morning forecast discussion, and just again, a few things to highlight. There was some concern with the widespread cloud cover that could limit how much CAPE could build. Yet there was a 2 or 3 hour window where surface-based storms could form along the front, and then further down in here, they do go on to say if the storms were to become surface-based, there was very good low-level shear. So this would favor an environment for an isolated tornado or two. So again, it was conditional, but there was some predictability there. And then I guess, it goes into where do you message and service there. Again, the probability, the risk seems so low that our hazardous weather outlook was just focusing on maybe some wind, maybe some hail, and the rain coming through. So again, getting to the idea of predictability, this was some of the work one of my cohorts did, Jeff Makowski, with our SUE's guidance on SPC's high resolution ensemble forecast system here, HREF. So this was the 12Z or 1200 UTC data valid for later that day, and you can see on the left the surface-based CAPE field. Again, it was going to be a close call in parts of northern Iowa, and kind of showed where that warm front was going to be right across the area. If you look at some of the shear parameters in this case, though, on the left, the 0 to 1 kilometer shear based on the forecast, pretty high as you would expect right along the warm front, and 0 to 3, perhaps even better with the storm relative helicity there. So suggesting that certainly could get rotating updrafts in that region. And then speaking of that, looking at some of the more newer fields, ensemble max updrafts, you can see a little bit of a hint across northeast Iowa into southern Minnesota, and the 2 to 5 kilometer updraft helicities too kind of had a little bit of a bullseye in the region there. So just going back to SPC analysis, just some quick comparisons between 10 a.m. and noonish that day. Again, you can see mid-level wave coming through. The 0 to 1 shears values, again, very favorable, again, as you'd expect along that warm front. And again, probably one of the keys is that keeping an eye on the dew points, the surface-based CAPE that, of course, is related to that. So there you can see some differences between, again, 15 Zulu and 17 Zulu with a definite northward push, and basically making an area that wasn't as favorable far more favorable. So we are looking at kind of one of these classic lower Cape, higher shear environments. This is a look at the RAP sounding out near Mason City or northern Iowa, valid for, again, about noon that day. And you can see the strong veering low-level wind profile with, again, kind of skinny Cape to be expected. So when I first started looking into this, I was wondering if it was one of these closed cold core low, kind of systems. And the more we looked at it, it was an open wave. So it really wasn't a classic cold core low. It also wasn't any kind of land spout or non-supercell environment. It was just more of a very favorable synoptic setup where you're advecting in much riper air, if you will, where you can quickly erode a more stable, cooler, rain influenced air mass. So I just kind of used the synoptic pattern classic example from some of that work with cold core lows coming by, just to kind of show you the relation as right before the tornado event started. So if we kind of zoom in again at, again, midday, you can see that, again, the dew point differences was key between, I don't know, a site like Charles City, Iowa here, where the dew point had climbed to 64, and up in southern Minnesota, again, it was still in the mid 50s. So just the difference between 5 or 6 dew point degrees or degrees can really make a climb in the Cape values, although not huge values of Cape, enough to certainly fuel some updrafts that led to these tornadoes. And there was very little, if any, thunder around too. I didn't really mention that at the beginning. It was pretty much tornadoes or nothing. So just to kind of finish up with look at our weather data here. Again, this is the 1700 visible loop and a view of the radar at 1700. So it's kind of interesting when you loop it. Again, you can see the approach of the wave, very favorable synoptic pattern for that warm front to maybe surge northward, at least a little bit of a northward push and make an area pretty ripe there. Just to kind of show you what it looked like on radar and the warnings that followed. Again, low Cape, high shear environment, so you're not going to expect much in reflectivity, but just enough of the stronger storms there that could tap onto that right along the warm front and produce the 7 tornadoes. I'll just let this run one more time here. All right, and then just looking at some of the other radar data, here's the rotational tracks, and kind of superimposed a view of, if you go back several slides, that 2 to 5 kilometer updraft helicity did fairly well off the HREF, the SPC HREF data for that time frame. Now, one of the challenges certainly is at the distance where the tornadoes started forming. You're at roughly 81 miles or so, maybe about 8,000 feet above the radar, or above the ground, I should say. And by the time the tornadoes kind of towards their ending tracks were maybe closer to about 5,000 feet. And some of the other radar fields here, including the correlation coefficient, and it is interesting. You can see a little bit of a debris signal right there towards the tail end as it left Lime Springs, Iowa, and got into southern Minnesota. All right, so just going back to services, just kind of thought I'd share how we kind of switched gears there. This was the weather story graphic that we had out that morning. We were still concerning about the flood risk of severe weather, but we did highlight the other conditional risks, if you will, from a lower risk to the north to greater, I guess you could say. But no mention at the time, at least, of tornadoes. One of our Graphiccasts that morning, again, talking about just kind of advecting this rain area through. So things changed quite a bit then as it got reassessed and started getting reports. This was a special weather statement, and this was about the tornadoes started when we started getting reports of tornado activity in the Charles City, Iowa areas. So try to give people, you know, kind of a heads up right as the warning process. And then the Graphicast kind of highlighting the risk of isolated tornadoes as the event started to unfold. So it was a good response, I guess you could say, to a quickly changing scenario. Interesting that an MCD did come out, but it really didn't have much effect on the forecasting skills, I guess you could say, at that point, because this was about 45 minutes into the reports of tornadoes at that point. So, you know, the risk was certainly observed, but didn't add a lot of value. I don't know how this is going to show up with the video, but I did have a couple of interesting videos from northern Iowa during this, and it kind of show you what the tornadoes look like out in the open farm fields. Of course, crops weren't up, it was a wet spring. But you can also see the very low cloud bases that would be expected with that type of setup, low LCLs. But some very interesting, relatively weak speeds, but multiple vortex signatures. And then I just wanted to quickly show one other little video segment, probably hard to see, but right in there with some of the wind turbines, there was a wind turbine right in the middle there that was hit, and some of the blades actually flew off, and you might see a piece of one of the blades kind of getting ejected there in the upper right part of the video there. It did damage several wind turbines in the area there. So in summary, just a few bullet items here. Again, in these conditional environments, you know, you have to have good situation awareness. You really have to put in that effort in the mesoscale analysis. It can be really crucial in especially needing to make updates or in one of these conditional setups. The mesoscale model output certainly gave or could have provided more confidence, and you got to watch for those changing parameters where are things getting more likely to produce severe weather or less likely, the hotter versus colder. One thing that, with the help of again Dan Baumgart, our science and operations officer, this is an interesting case in a sense that you've got rain around and you have questions about how much instability could actually form. But in these very highly advective cases where you can change the air mass, you know, again, with the dew points only needing to go up about 6 degrees or so, you can often discount that earlier concern about stability with the rain. Combinations of these parameters too, you know, several different parameters becoming more favorable can combine to make a less than ideal scenario much more favorable. And, you know, the services and messages that we have out in these cases need to change just as quick. So you really kind of have to be all boots to the ground there when you're making a change for things that are occurring that maybe weren't in your additional messaging out there. So just a few references, and again, I wanted to thank the lead class here for arranging these. Was originally going to present this in Ankeny, Iowa, at the Central Iowa NWA conference, but so I wanted to share my thanks for them taking my accepted paper there, and then of course the support I got from the office and from the SPC, Dan and Jeff there. So that's all I have. Again, thank you for letting me present here.